Good evening. I'm going to take a guess and say that there are a lot of architects here. Maybe. I am one too. And I'm posing the question because I think then you would recognize what this is. This is an example of the current state of our building technology. This is BIM. And what BIM reveals to us is an interior space that's actually a technological space. We're looking at a space that's highly controlled. We're controlling data, we're controlling things like plumbing, electricity, and we can ever more finely tune this space. But when we go outside of the building, we're left in chaos. We're left to weather systems, things like pollution, radiation, noise. This outside in our cities is a highly active, volatile environment, and our architecture is not making any reference to it. Forces are acting on our buildings. Climate is acting on our buildings. But the actual bricks and mortar of our buildings are inert. We have cities that have vast amounts of surface area, like this one, that are basically doing nothing to interact with those systems that are acting upon us. These surfaces have potential. These surfaces can be activated. And what I want to show you tonight is two projects stemming from my work. I have two companies, so no one gets confused. I have Elegant Embellishments, which is a company looking at air pollution in cities. And I have Made of Air, which is looking at global warming and using CO2 as a material resource. Both projects serve to illustrate the point that buildings can be active in reversing climate change. So yeah, that's me. That's back in 2006. And this is about the time that I was forming Elegant Embellishments. And the company is formed as a platform to self-initiate products, building products that can interact with climate. And this particular photo, I'm learning how to cast my first prototype. This is in 2006, and I'm in the back room of Hackney Wick somewhere. And it was a big learning curve. And the product that I was prototyping was a new facade module that would reduce air pollution in cities. The technology came at about the same time. It was on the rise of smart materials in London at the time. It's a titanium dioxide-based paint, and it uses light to convert, just sunlight, to convert harmful pollutants in the air to harmless byproducts. It's a paint. And to scientists that we were working with, the patent holders as well, it looks like this. But to the rest of us, it looks like this. So my problem that I was trying to solve with my prototype was pollution. And pollution is this invisible problem. And here comes this great solution. It's a near invisible solution to my problem. I have a white paint that's formless. And so as a company, we challenged ourselves to see if we could get that coating to be more effective, to be more visible, and to be able to cluster it onto buildings where it could be more effective. So we're really big into corals. In the biological world, there's this link between surface enlargement and light. And we thought with this light-activated technology, we started to think about a hypothesis for our product. Could we use surface enlargement to enhance the efficacy of this technology? And this is the product that resulted from it. This is Prosoft 370E, and this is a facade module that reduces urban air pollution. And basically what we did was design a substrate for this technology that would provide surface enlargement, so it had a lot more efficacy. We used a kind of strange pattern. I don't know if anyone recognizes this pattern, but it's a Penrose pattern. And it means that it has two repeating elements, but the pattern never repeats. So we get omnidirectionality, we get like a random effect, but still with the economies of scale to build it. And the shapes themselves are actually shaped to slow down wind speeds so that we can collect more pollution on the surface over time. In 2013, we put this one on a hospital in Mexico City. That's some photos of it. And that is a 2,500 square meter solar shading screen that also reduces pollution. And what it's doing is pulling the pollution of about 1,000 cars out of the air per day. It's a piece of architecture, it's a facade, but it's also the biggest, I think the world's largest urban air purifier. We're based in Berlin, and we work wherever air pollution is. So we have projects around the globe. The project we're doing right now is in Ivory Coast. It's very exciting. This is a 4,000 square meter facade. It's the headquarters for Orange. I think we're on site in, I hope, 2 months. This is also a geometry first for us. This pattern that we've been working with, it's a quasi-crystalline pattern. We're putting it here on a doubly curved surface, which is incredibly complicated. This is the lay of the construction products land. I think if there are architects here, I think you know this. Most products we're buying to put on buildings are flat, they're rectilinear, they transport easily, they're lightweight. And we, as an architecture company, wanted to make something like that. And that just didn't fly with the building industry. So manufacturers didn't want to make it. And what we had to do was look for an industry that would. Our shapes are a lot closer to an industry that's been making them for over 100 years. And what we realized was we had to make a deal with the industry that had caused our problem. And what dawned on me later was, if your problem is in the air, then your solution has to involve aerodynamics. And I think this shift in thinking, this inter-industry jump, is really important when you're dealing with climate, because climate does not accept standards. It doesn't know any straight line. So you have to be able to think differently. Our evolution has been full of gaps. We've had to learn a lot. And when we didn't know something, we had to become experts in that thing. And this means we had to do like deep dives into polymer science, into microchemistry. We know a lot about wind dynamics now. And it's been an interesting journey. I think what we're quite comfortable doing is designing and manufacturing a product that follows a norm. Our products tend to act like a kind of Trojan horse when we're using the kind of business as usual function of a facade or a solar shade, but actually what we're doing is fighting climate. And I think that works both ways for our clients too. I think they're kind of comfortable with that double bottom line. Who has time to read? I don't. But I did. I read this book, The Martian, and I read it at the same time as the Paris Accord. And I couldn't help but draw parallels between the whole thing, because this is Matt Damon here. He's sitting on Mars. If you don't know the story, it's really good. And he's having to precipitate things out of the air to survive. And he's looking at scarcity, and he doesn't have anything, and his planet's not giving him anything. And I'm thinking that's exactly how we need to think with climate agreements like the Paris Accord. And so I started thinking about the air, and what can we get from the air, and where are our resources actually going to come from anyway? So what's in our air? I already had spent a lot of time with air pollution. I knew about that. But the bigger thing is that we have a lot of carbon dioxide in the air, a lot. And we became really interested in how this problem, this stuff in our air, could be turned into a solution, and how we could get it maybe out of the air and start using it to build our cities. We have another problem. Our population's about to explode. I think climate scientists are predicting that building for the next 2 billion people is going to emit so much CO2 into the atmosphere that we're going to kill our Paris Accord agreement just in construction materials, which I find crazy. But it illustrates the point that materials are important. And materials can go either way. Materials can sink us or they can save us. This is the new normal. We're looking at CO2 as it's here to stay. What are we going to do about it? Our regulations are advancing. We see a lot of cities lining up for climate targets. And we're looking at how we can take this future building that we need to do anyway and turn it into something that can be more active against the problem. So this is one technology that we came across that fueled our startup, which I'm going to tell you about quickly, because I'm running out of time. And it really has to do with biomass. It's a very simple thing. It's photosynthesis. And if you look at all the plant material around you, what it's doing all day, every day, during the day, is collecting all the CO2 out of the atmosphere. But when that plant dies, it re-releases the CO2 back up. So it's a carbon sink, but only for a little while. If you were to take all that biomass and bake it without oxygen, you would be able to convert the CO2 that it has in its cells into pure carbon. And this is a usable material for us. So I'm going to tell you about it. My startup is called Made of Air, and I formed this company around this idea of making CO2 from the atmosphere a usable material. We've produced a thermoplastic, and this is a carbon negative material, which means it has so much CO2 from the atmosphere in it that it generates negative emissions just by being made. It's formable into products because now back into the building industry, this is an important way that we can link the urbanization that we're facing in cities back to the problem. So the more we make of this material and products like these out of this material, and the more we get them onto our buildings, the more we link them to how much we have to build anyway, the better we're going to be off, the better off we're going to be environmentally. So this is a prototype of this material. It's called HexChar. It's just an example of what we can do with the material. This is, it's finishing its testing. It's looking for pilots, if anyone's architects, if anyone's interested. We are looking at projects that will start to highlight this point about buildings being more active in using CO2. Some numbers: if you have 1,000 square meters of this material on your building, you have 126 tons of CO2 saved on your footprint, and that's just in the facade. So, the future, is it going to be all black? Maybe. Maybe. I think about this a lot because I'm a big fan of futurists, as in the futurists in the past. And I think about what they imagined our future cities were going to look like. And I think they had this idea that we would have these crazy shapes, that we'd have this like gravity-defying architecture and zooming transport and stuff. But I don't think they could have anticipated the mess that we're in right now. African cities are supposed to urbanize by 790%. And traditional sustainability says we shouldn't be building. So we need a solution. We need a material solution for this problem. And a new carbon economy is emerging through technologies like this. And it will replace the fossil economy. And my proposal is that we build our future cities with the stuff in our atmosphere. Thank you.